Hi there. What we're going to do today is we're going to continue with our work with quadratics by graphing. Okay, you have in your documents the graphing a standard form of a quadratic, right? And we are asked to graph y is equal to x squared minus 2x minus 3. Okay, earlier this week we learned how to factor this. Okay, and I've already factored it. It is going to be x minus 3, x plus 1. I have identified the value in front of my leading coefficient because we're going to see this. I'm going to turn this. Ax squared plus bx plus c is the standard form of a quadratic function. I have labeled my a value, the leading coefficient, which is 1, the b value, which is negative 2, and the c value, which is negative 3. I'm going to show you where we're going to use this here in just a minute. Down at the bottom of the page, I have some important vocabulary. I am going to let you pause the video, okay, if I'm going too fast, and you can copy it down in a little bit. The y-intercept is where the graph crosses the y-axis. The x-intercept is where it crosses the x-axis. The x-intercept can also be called the roots, the zeros, or the solution of the equation. Okay? The vertex is either the lowest or highest point of the parabola. The parabola, and I'm going to skip down here to this a value, my leading coefficient. Okay? If the a is positive, it's going to open up. That means that it would have a lowest point. If it is less than 0, it's going to open down, which means it would have a high point. If it opens up, the parabola is going to look something like this, like a big smiley face, okay? And so the vertex would be at a low point there. If my a value is less than 0, it's going to open down. It's going to look something like this, and my vertex would be the highest point of the graph. All right? So you can pause this and look back up here. Oh, I forgot. The axis of symmetry. That is very important because we have a formula over here, and that's what we were doing up there. The axis of symmetry is a line that divides the parabola evenly. Symmetry means something is symmetric across a line, right? It means it's the exact same on both sides. A parabola is symmetric. That means that it is going to be the exact same across this line of symmetry, or the axis of symmetry. So my formula for finding that axis of symmetry was negative b over 2 times a. So my b value is negative 2, my a value is 1. So negative b, which makes that a positive 2, negative times negative is positive, over 2 times the a value, which is 1. I have 2 over 2. My axis of symmetry is across a line. X is equal to 1. So I'm going to x is equal to 1, and I put a line right down through here. Okay? And this is my axis of symmetry. And we found that by x is equal to negative b over 2 times a. And it is a line across x is equal to whatever that number is. Right here, ours is x is equal to 1. And I have a line right there. You don't always have to make a line right there, but that's what I did. All right? So the next thing that we can find is our vertex. And I know this is going to be my vertex. Okay? And I find my vertex by, when I have this x is equal to 1, I'm going to put it back into my original equation to find out what my y value is. So y is equal to, and for the x, I'm going to substitute 1. 1 squared minus 2 times 1 minus 3. And I get that y is equal to -4. So my vertex, right, will be 1, -4. So I go 1 and then down to -4. 1, 2, 3, 4. Right here is going to be my vertex. My vertex is 1, -4, and I find that by -b over 2 times a. That's where I found the 1. And then I put it back into that function, f of x, to get the -4. I put it back into my equation and got the y value. That's where I got the -4. 1, -4. That is going to be my vertex. Now, I can put in equations here, I can put in x values here. If I put in 0, my y-intercept is at -3. So here's my y-intercept. Right? Then I can look up here. Remember how we factored and I was going to show you what these were? These are called the roots, the solutions. These are also called where they cross the x-axis. What value of x would make this 0? +3. So I have x minus 3 and an x plus 1. If I want to know where those are 0, if I put in at +3, that would make this whole thing 0. And at -1, that would make it 0. So those are where it is going to cross the x-axis. When I factor it and find out the places where those will be 0, those are going to be my x-intercepts, my roots, my solutions. I have an x-intercept. Right? Now, I have points, and I can go ahead and I can sketch my parabola by connecting them. And my parabola is going to look something like that, right? We've gone through a lot of information today. We have looked at the standard form, ax squared plus bx plus c. We've identified our axis of symmetry when we put these values for our graph into our formula. X is equal to -b over 2 times a. Here is our formula. When we get that value, we put it back in our equation to find out what the y value would be. That's our vertex. We've identified where our y-intercept is and our x-intercept, and then we sketched our graph. Today, what you are going to do, you are going to, on the other side, you're going to find the vertex and the axis of symmetry. You're going to solve for the axis of symmetry using our formula. X is equal to -b over 2 times a. And then you're going to substitute that value back into your equation and find your vertex. That's what we're going to do right here. You have one problem to do. You can put it in Desmos and answer the question.